Welcome to aminacademy.com. In strength of materials, let us discuss about strength of solid and hollow shaft. We know that strength of a shaft means the maximum torque or power it can transmit. As a matter of fact, we are always interested in calculating the torque that is a shaft can withstand or transmit. Let first we'll discuss about strength of a solid shaft. This is a X here R. Let R equal radius of shaft in mm. Tau equal shear stress. Shear stress developed in outermost layer of the shaft in Newton per mm square. Consider a shaft. Your torque T is shown in figure. Torque is applied. Now let us consider an element area dA. Consider then elemental area of dA with distance from center is x, thickness is dx. Now that elemental area equal dA. Now I can say that dA equal to circumference and with thickness. Circumference is 2 pi x into thickness is dx. So the area dA, elemental area is dA equal to 2 pi x dx. Now shear stress at this section. Shear stress at this section means here shear stress at this section is, let it be tau x equal tau into x by r. That ratio, that is x by r into tau is shear stress at this section. Now where tau is the maximum shear stress, and tau x is shear stress at the section x distance from the origin. Now turning force. Turning force is shear stress into area. Shear stress is tau x into area dx, which is tau x is already we have tau into maximum shear stress at x by r into x by r dx. Tau x dx, which is tau x by r into dA, that elemental area. Now which is further equal tau into x by r. dA is already we have 2 pi x dx. 2 pi x dx. So which is further equal to pi x by r tau by x by r. Here one more x is there. that is 2 pi x squared dx. Now we know that turning moment of this element, turning moment of this element, turning moment of this element is, let it be delta T, that is turning torque, is turning force into distance of that elements from the shaft, that is x distance. Turning force into distance of an element, distance of an element from the center, which is equal, therefore dt equal 2 pi, this is tau here, and 2 pi tau by r into that element distance is this x square into x dx, which is equal 2 pi tau by r x cube dx. This is the turning moment of this element, but we need turning moment of this complete shaft is integrating with the limit of 0 to r. Therefore, total turning force T equal integral of 0 to r 2 pi tau by r x cube dx. Take out the constant of integration taken out, that is 2 pi tau by r 0 to r x cube dx, which is equal, integrating this x cube is x power 4 by 4, that is 2 pi tau by r x power 4 by 4 with the limit 0 to r. Substituting excess r, we have 2 pi tau by r power 4 by 4. Now this which is equal 2 pi tau r power 4 divided by r is r cube over 4, which is further equal 2 pi tau by 4, r can be written as d by 2, the diameter by 2 whole cube, which is equal, here then this 4 and 2 is cut as 2, then 2 cube is 8, 8 into 2 is 16, therefore pi by 16 d cube tau d cube. Therefore, the torque, that maximum torque torque is pi by 16 tau d power 4, d cube, sorry, d. This is a formula for the torque can transmit. Now, strength of hallow shaft. Seam here from this is a hallow shaft with radius, small radius r, and outer radius is capital R, the same dA, area dA with the distance of x. Now the same procedure for a hollow shaft. Therefore, d everything, but here r equal to inner radius and r equal to outer radius, and like that d equal to inner dia, d capital D equal to outer dia. Now we know that dt, previously we have dt equal to this. Here instead of same dt by dt equal 2 pi tau over r x cube dx. Here the integration limit is r to r, not 0 to r, because it is a hollow shaft. Therefore t equal 2 pi rho by r x cube dx with small r to capital R. We have, after integrating, we are getting final result as torque equal pi by 16 into tau into d power 4 minus d power 4 by t. That means that same procedure we have to follow, but the limit of integration is r to r. Newton per mm, Newton meter, Newton mm. Here also Newton mm. Now we'll do an example problem regarding this concept. A hollow shaft of external and internal diameter of 90 mm and 60 mm is required to transmit a torque from one end to the other end. What is the safe torque it can transmit if the allowable shear stress is 45 MPa? Here the outer dia is 90 mm, inner dia is 60 mm, torque tau equal 45 megapascal, and then apply the result. T equal, for hollow shaft, that is pi by 16 into tau into d power 4 minus d power 4 over d. So capital D. Now we will apply the values, which is equal pi by 16 into tau is 45 MPa and d is 90 power 4 minus 60 power 4 over 90, which is equal pi by 16 45 into 90.4 minus 64.4 over 90 is equal to 58,500. After simplifying this, we get approximately 5.1663 into 10 power 6 Newton mm, because this now we are using this as megapascal and this is in mm, so it gives Newton mm, which is, look at here, Newton you can use kilonewton for 10 power 3 and mm meter for mm power 3. So total 10 power 6 is used, therefore you can say it is 5.1663 kilonewton meter. We have done. So far we discussed about that is a torque maximum strength, that is the strength of solid and hollow shaft, that is maximum torque it can transmit, like solid shaft as well as hollow shaft. We have done. Please subscribe our YouTube channel.